Hello everyone. So today is possibly the second last video of this particular playlist where we are elaborating on the code of crack propagation. So in today's video we will generally be discussing the codes of setting velocities and fixing environments. So initially I would like to go over the definitions. So what does velocity mean? The velocity command in LAMMPS is used to assign initial velocities to atoms or groups of atoms. So you can set or assign different kinds of velocities to atoms, and this is based on different distributions, assigning a specific temperature, adding translation and rotational motion. So we will go in details about the velocity and fixed commands, so you will understand what does distributions, temperature and translational motion, what does these have to do with velocity. So in case of fix, the fix command applies ongoing operations or constraints to groups of atoms during the simulation. So you are applying different kinds of constraints or operations to a particular group of atoms when you are running your simulations. So this particular type of operations may include maintaining the temperature, applying external forces, controlling pressure or outputting data, etc. So first we would go over the velocity command. So if you can see here that velocity group ID style args keyword value. So firstly, velocity group ID. So you need to specify which group of atoms you are trying to assign or set the velocity for. This is what the group ID is. So it is a specific ID for a specific group of atoms, or you can just say that you are applying velocity to all the atoms. That is also an option. Next you can see style. So style means what kind of operation you are trying to do. You may try to create velocity, you may try to set velocity, you may try to scale velocity. We will go into each of these styles later. Next you can see arguments and keyword value. So arguments mean under each style there are specific arguments which you can use to say which kind of style you are applying, and the keyword value indicates the values you might be using to further define that style. So let's go into the details. So if we go to the examples, we will have a much clearer idea. So for the first example, you can see that velocity all, which means you are assigning the velocity to all the atoms within your system. Next you can see create 300. When you are using create, what you are doing, you are assigning random velocities to atoms based on a particular temperature. For example, you want your temperature to be 300 Kelvin. Now you can say to the atoms that you have to move in velocities so that I get a temperature of 300. So you are assigning, for example, this may move at a velocity of x, this may move in a velocity of y, but the main goal is setting the temperature. So this is what you are doing. And in case of this distribution of velocities, that you are assigning them randomly. So this distribution can happen in multiple ways. For example, one of the distribution is normal distribution, in which case you are saying that all the atoms in your system will have a particular value of velocity, which is not very common in nature. In nature we can see some sort of Gaussian distribution, which we have also used in our particular code. So Gaussian distribution means that our velocities will maintain such a graph in which the majority of the atoms will have a velocity in a particular range, while there would be a few outliers. So this is what it means by Gaussian distribution. Here you can also see rotation yes. By rotation yes, what it means is that your linear or angular momentum would be equals to 0. So this is what it means. Next you can see that 492849459. So this is a random seed value. Why is it important? Since you are assigning random velocities to the atoms, if you do not use a seed value and you run the simulation again, you will not get the exact same results. So your results will vary. So to reproduce the results, you need to assign a particular seed value. This is what I am doing. Next, you can see velocity border set null for VZ. So what it means that of the group of atoms named border, you are setting the velocity and you are setting it along three directions x, y, z. X, you are setting it null, which means that it is not changing. Along the y direction, you are setting it as 4, and along the z direction, you are setting it as vz. Here vz is a particular velocity according to a variable. Next, you can see here it is written sum yes. So sum yes means that, for example, let the atoms in your system might have a particular velocity. So now you are setting a new velocity. So your new velocity might be added to the particular velocity they already have, or it might replace the velocity of the atoms currently active in your simulation box. So when you are saying sum yes, it means that it will add to the velocity present with the velocity you are commanding or setting it to. So this is what it means by sum yes. Next, you can see units box. So in case of LAMMPS simulation, there are a lot of units that we can use. So units box is a popular type of units that which is referred to in this example. Next, you can see flow scale 300. So you are setting or you are scaling the velocity of the atoms present in the group named flow. Next, you can see that you are ramping it. So what does ramping mean? Ramping means you increase the velocity of the atoms in a particular rate. And you can see that 0, 5, y 525. It means that the x velocity, that is the velocity of the atoms, can be along the 3D, like it can be along the x-axis, it can be along the y-axis, it can be along the z-axis. So now what you are doing is you are taking the x velocity and you are ramping it, and you can see that you are ramping it from 0 to 5. It means that your initial Vx is 0 and your final Vx is 5. But what you are doing is, this is the motion of the atom, but you need to specify like in which atoms you are applying this velocity to. So you can see here y 525. It means that when the value of y equals to 0 and the y equals to 5, all the atoms present within these dimensions, the x velocity will change from 0 to 0 to 5. Okay, so in this way you are setting borders for the velocity, direction for the velocity, as well as you are setting the borders and direction for the coordinate system. Next, you can see temp my temp, which means that the temperature you obtain from these velocities will be stored in my temp. And lastly, you can see velocity all zero linear, which means that all the atoms will have zero velocity. Normally in the linear means the linear momentum would be 0. Okay, so now this is all the basics that come along with the velocity command. There are some other things which you can learn when you go into the specific applications. Now we would go to the fix. So what does fix mean? Fix means that you are fixing particular forces or operations or constraints to a particular group of atoms within your system. So here you can see fix ID, group ID, which means that group ID means that, for example, if you can remember, our system is something like this. So this is a group, this is a group, this is a group. So you are fixing a group ID, and among this ID you are also fixing different identifiers, because for a particular group you can apply different operation, like you can apply temperature, you can apply force. So you need to specify which operation you are talking about. Why is this important? Because in some cases you may need to unfix, like after fixing a operation you may need to remove it or you may need to modify it. So you need to also specify the numbers, or you may need to assign identifiers to the fixes you are applying, along with specifying the group of atoms you are applying the fixes to. I hope this makes sense. Next, you can see style and arguments. This means that you are applying a particular style of fix, and along with each style comes different arguments. So now I would go into some examples so that it would be more clear. Here you can see fix 1 all NVE. 1 means this is our first operation and we are assigning it to the variable 1. So when at the later part of the code, if I use unfix 1, it means that all that we are fixing to all the atoms, it will be unfixed, which means this operation would be cancelled. In this way we can easily cancel the operations if we assign a particular identifier to the fixes we are applying. Next, you can see all. All means we are applying this for fix to all the atoms present in our simulation box. Next, you can see NVE. So in this group, in this code, we are talking about two kinds of fixes, NVE and NVT. So what is NVE and NVT? NVE means the number of particles, the volume of the system, and the energy. These three are constant. So if you can relate with the thermodynamic systems you might have studied, you will understand that this only happens in isolated system where your energy is constant. So when do we use NVE? We generally use NVE before or after, that is during the equilibration process, so that in that time our temperature might change but we are not exchanging any sort or any form of energy or force with the environment. We are letting our system go through different changes in temperature while maintaining its energy. So that is when NVE is applied. Next, you can see NVT, which means that number of particles, the volume, and the temperature is constant. So what does it mean to make the temperature constant? So you might apply some sort of isothermal expansion or contraction. You might need to work with a particular temperature while maintaining the temperature. So this is when NVT comes in, and to make the temperature constant we need to use different sorts of thermostats or thermal baths. So there are different kinds of thermostats that we use. For example, Nose Hoover or Langenin. So there are different kinds of thermostats. So based on your system, you need to select what sorts of thermostats we are using. So thermostats are basically an algorithm which helps you to maintain the temperature of your system. Next, you can see 300 300 0.01. So what does it mean by 300 300 0.01? So by this you are mainly saying what kind of thermostat, what kind of temperature you are maintaining, what is your initial temperature, what is your final temperature, and this 0.01 is based on your thermostat. So this is a property of the thermostat you are using. So in this way you can also use set force 00 null 0, which means that you are setting the forces along the x and z axis as 0 while you are not changing the force along the y-axis. So this is all for the velocity and fixed commands. Now I would go through the code so you can understand what is happening. So initially you can see compute new mobile temp. So what you are doing is you are computing all the temperature of the group mobile. You can as you can remember that we have assigned the group name mobile to a particular group of atoms, and now you are computing the properties, that is the velocity and the temperature of the mobile group, and you are storing it within temp. Okay, so now we are applying the velocities. You can see velocity mobile, which means you are setting the velocity of mobile, creating, you are assigning random velocities. 0.01 means the temperature. This is 0.01 Kelvin, or this is mainly the temperature. And in case of this particular system, this 0.01 might not be Kelvin, because your units that you are using might be different. This is the random seed value, and this temperature which you have generated through the velocity would be stored in nu, which you have already declared. Next, you can see velocity upper set 030, which means that velocity of the upper group of atoms will have three velocities. In the x, Vx, it will be 0, Vy, it will be 0.3 units, and Vz would be 0, which means that in the upper group, the velocities in the x, y, and z direction have been defined. Now what we will do is we will be ramping the velocity. Initially, the velocity of along the y direction would be 0, but it would move or increase to 0.03. The velocity y equals to 0.03 is not what you will get initially. Initially it would be 0, later at the end it would be 0.3, and you are ramping it. You are ramping the Vy velocity, and you are ramping it while moving from y equals to 1.25 to y equals to 1.25, 38.75, which means that along the x and the z direction, your velocities will not be changing. It will only change along the y direction. Next, you can see sum yes. Sum yes means you are adding the velocity to the existing velocity that is already present within the system. Next, you can see fix one all NVE, which means you are saying that this is the number one fix, and you are assigning it to all the group atoms present in your group, and you are applying NVE, which means that you are maintaining your system within an isolated environment where the energy is conserved. Next, you can see fix to boundary set for null 0. So with this, you are setting the force along the three directions as null 0, 0. So this is basically what we can understand from this part of the code. In the next part of the video, in the next video, I will be going over how you can get the outputs from the simulations you have run. So this is all for today's video. Thank you.